Okay, so let's say we wanted to determine whether these two lines are parallel, intersect, or are skew lines. Okay, so the first thing to do is to check whether the direction vectors are, well, going in the same direction, okay, if one is a multiple of another, okay. So we've got 3, 2, 1 and 1, 1 minus 2. So what you need to convince yourself of is that there is no value of k that I could put there so that 3, 2, 1 is equal to k lots of 1, 1 minus 2, okay. So clearly k would have to be 3 in that case, but 2 is not equal to 3 times 1 in that case, so it doesn't work, okay. So they are not parallel. So if they're not parallel, then what we're then going to do is set up these 3 simultaneous equations, which come from the top rows, middle rows, and the bottom rows. So we've got 1 plus 3 lambda is equal to 2 plus mu. We've got 6 plus 2 lambda is equal to 5 plus mu. And minus 5 plus lambda is equal to 7 minus 2 mu. Now, when you're working with 3 simultaneous equations and 2 unknowns, what you need to do in your methodology here is choose 2 of the equations and ignore the third, solve for the 2 equations that you've picked, and then substitute your values into the third equation, the one that you haven't used, to check whether it works. Okay? So what I'm going to do is I'm going to pick 2 of the equations. It doesn't matter which 2 you pick, okay? But probably best to pick the easiest ones. So I'm going to pick numbers 1 and 2, because then I can do equation 1 take away equation 2, because I can then cancel the mu's. 1 take away 6 is minus 5. I've got 3 lambda take away 2 lambda, so just plus lambda. 2 take away 5 is minus 3. And the mu take away mu is 0. So that means I can then add 5 to both sides and get lambda must be 2. You can then substitute that into either 1 or 2, not into 3 just yet, okay? So completely ignore 3 for the moment. So we're going to substitute that into equation 2. And we're going to get 6 plus 2 lots of lambda, so 6 plus 2 lots of 2 is equal to 5 plus mu. So 10 equals 5 plus mu, and so mu must be 5. Now once you've got your lambda and mu, you can substitute them into the third and final equation. So sub into 3 now. So we get minus 5 plus lambda, so minus 5 plus 2 is equal to 7 minus 2 lots of mu. So 7 take away 2 lots of 5. So the left-hand side is minus 3. The right-hand side is 7 take away 10, which is also minus 3. And so the lambda and mu work. And so that we've found lambda and mu, that tells us, and that third one worked, that means that they intersect. Therefore, L1 and L2 intersect. Now it makes sense then to find where they intersect. Now, you can either substitute your lambda into that, or you can substitute your mu into that. It doesn't matter which one you do. So I'm going to show you both, just to convince you that it doesn't matter. So lambda was 2. So we've got 1 plus 2 lots of 3. So 1 plus 2 lots of 3 is 7. 6 plus 2 lots of 2 is 10. Minus 5 plus 2 lots of 1 is minus 3. Okay? And if you substitute mu is 5 into this one, into line 2, you get 2 plus 5 lots of 1 is 7. 5 plus 1 lot of 5 is 10. And 7 plus 5 lots of minus 2 is minus 3. Okay? And so that, as you can see, they're both the same. That is where those two lines intersect.